Hi everyone. I decided to make a tutorial on how to analyze the basic dynamic analysis samples. This tutorial will focus on mystery.exe executable we analyzed in class. Before we begin, I would like to point something out that I haven't really pointed out enough before. When you're doing your malware analysis, it's very important to document every single step. Document, document, document. Every single finding you make, write it down, take a screenshot, and jot down any thoughts that you may have. This is very important and it will help you to come up with a conclusion. So let's get started analyzing mystery.exe. So the first step that we should do is let's submit it to VirusTotal and see if this is a known malware sample. So what I'll do is I'll compute a hash of this executable and I'm going to submit the hash to VirusTotal to see if VirusTotal is already familiar with a malware sample that has this hash. And it looks like 3 engines out of the 67 have detected it as malware. So the silence engine is pretty interesting. It says that this is a Trojan and this is a starter Trojan. In other words, it thinks it's a Trojan horse that starts on system startup. So we're going to take a note of that and we will use it in our analysis later. So I'm going to take a screenshot and your VM actually comes with that nice feature. If you go to view and you click on take screenshot, it will save a screenshot of your VM. All right. So I'm going to save this on my desktop and I'll call it VirusTotal. And I'm going to make a note in this report right here. I'll say that silence engine detects this malware as a Trojan starter. All right. The next thing which I'm going to do, I'm going to take this sample and I'll try to figure out, is it packed or is it not packed? So to do that, I'm going to open up exe info p and I will put the mystery.exe executable into that. So according to exe info pe, this is not a packed executable. However, it does tell us one interesting piece of information, that it has been compiled using a C++ compiler, and it looks like it's been developed by Bloodshed Software. It even has found the URL of the compiler's developer. So we can briefly visit that just to see if there is anything interesting there. And it looks like it's a pretty old compiler. The last version was released in 2005. So again, this malware was developed using a what looks like a legacy compiler. So in my notes, I'm going to write down the malware sample does not appear to be packed, and it looks like, according to exe info p, the malware sample was compiled using Bloodshed Software, and we can add the link that we have seen in case this will be useful. Let's see what we got so far here. So we know that some engines think that this is a Trojan starter. Again, a malware that starts itself on the startup. And because we know how Windows registry works, we may be on the lookout for changes to registry that add programs to the startup. We're going to be keeping this in mind throughout our analysis. Now, because we concluded that our malware is not packed, then we can go ahead and we can examine its imports to see what functions and files it actually relies on. As usual, I'm going to open up the dependency walker and I'm going to put mystery.exe in there. So let's see what it actually imports. Well, it imports the file advapy32.dll. Now, if you do a little bit of research online, you'll see that this DLL has to do a lot with registry operations. And if we look right here, from this DLL file, the program imports the following functions: reg close key, reg create key, reg open key, and reg set value. Now, those are registry functions used for opening registry keys and creating registry keys. So I'm going to make a note of that as well. I'm going to copy the function names and I'm going to add them to my notes here. So I'm going to say the program imports the following functions from the advapy32.dll file. All right. Now, once again, this jives well with what we already learned. So once again, Silence thinks this is a starter Trojan, and one of the ways that a program can get itself into startup is through registry. And according to this, we now found out that the program makes use of registry functions. So if the program was to add itself, or perhaps some other piece of malware, as a startup program, well, it would rely on those registry functions. That's actually exactly what I would expect to see. Now, as we delve deeper into our analysis, we will be on the lookout for registry-related stuff, especially the stuff that can result in the program being added to the startup. Now, another thing which I would like to do before we go on, I also would like to run this program through pview just to see what kind of information we can get about the sections of the file. So if we go to the NT headers and if we look at the image file header, we find out that this is the compilation date. And another thing which I would like to take a look at is what kind of program is it? Well, it's a 32-bit executable, and also I want to find out what kind of program is it. Is it a GUI program or is it a command line program? And we can find it out by looking at the subsystem. So according to this program is a console program because it says image subsystem Windows CUI. So we're going to say that this program was compiled on 2018-09-18 and that this program is a 32-bit console application. The next thing which I would like to do is look at the strings. Now, and once again, I'll be interested in all registry strings, especially the strings that are related to the program startup. So to do that, I can either use strings program or I can use the PE Studio. So I'm going to give the PE Studio a try. So I'm going to start PE Studio and I'm going to drag in mystery.exe, and then I'm going to look at the strings portion. And according to the strings portion, I can see some interesting things already. PE Studio says that right here is a string that is related to the registry, and look at that string. Software, Microsoft, Windows, current version, run. When I look at this in the context of what I already know, I already suspect that this program is a startup program, or somehow it adds other programs into the startup. this is what I would expect to see. So it has a string that is definitely a registry string. There is also what looks like an executable name, evil malware. Once again, both of those things, they pique my interest. So I'm going to copy those values and I'm going to add them to my notes. So I don't see anything here. Looks like some standard stuff, some gibberish. Well, this is interesting. This looks like part of the registry path, especially based on the name, key and subkey. And this looks like a potential output string. So I'll definitely copy those and I'll add those to my report. As you can see, folks, as we're doing this, we're getting more and more evidence that corroborates the fact that this is a malware that messes with registry in order to add either itself or some other program into the startup. Either way, we are pretty confident that somehow this thing has something to do with the startup. All right. Now, let's take a look. Oh, and there is an evil value. That can definitely be something of interest. So I'm going to take a note of that. Let's see if we can find anything else. So I can see a bunch of important function names, gibberish. Well, this is not gibberish, those are the names of the sections. But once again, I don't see anything unusual here. So I'm going to look through all of this. But so far, nothing too interesting. Looks like a bunch of standard stuff. Yeah, more standard stuff or things that we already know. So looks like this is the only information that we'll be able to glean so far. Now, since this program appears to be a program that somehow messes with a startup, I'm going to proceed onto dynamic analysis, or I should say basic dynamic analysis, where I'm going to run this program and I will monitor it with Procmon Process Explorer. And I'm also going to create a backup of the registry because I suspect this program will modify registry before I run this program and after I run this program. Now, because I suspect that this program will be modifying registry, I'm going to start Procmon. It's always a good idea to use Procmon for all dynamic analysis because it gives us so much useful information. And I'm going to configure the filter of Procmon to only include processes that are named mystery.exe. So I have added that filter. I will also run Process Explorer in case this program hangs around long enough for me to see whether it connects to any ports on the network. Now, if this program terminates quickly, then Process Explorer won't tell me much, but I will run it in case the program will stick around. Also, because I suspect that this program will be messing with the registry, what I like to do is I would like to take a snapshot of the registry before I run the program and after I run the program. So to do that, I'm going to run regshot and I'll take the initial shot of the registry. And then once I run the program, I'm going to compare and see if the shot before and shot after have any interesting differences. All right, so now that has completed. Now, I don't have any reason to suppose that this program will be doing network communications because based on our initial static analysis, we have not seen the program import any networking DLLs, nor did we see any functions that are indicative of networking. However, maybe the malware is doing network communication through some other means. Perhaps it has some kind of a statically linked library that it relies on for networking. So just in case, I'm going to start a PATE DNS so I can intercept the DNS requests of the malware, should it make any. And I will also start up Wireshark, which will show me all communications going in and out of my system. So if the malware calls home, I'll be able to see it right here. All right. So I think everything is ready. So I'm just going to take a snapshot like we always do. And I'm going to run the program. There we go. All right. So I'm going to now look at what happened. Now, the program has already terminated, so I probably won't see anything interesting in Process Explorer, and I did not see this program start any new programs to the best of my ability, but I'll be able to tell more by looking at the Procmon capture. And also another thing which I'll do is I'll now take a second shot of the registry. Normally I would do this right away. And I'm going to compare the two shots. So I'm going to find out, are there any differences between the registries before and after the snapshot. So I'm going to click compare. All right. Here is what we see. It says that the malware has added two keys. So one is called malware subkey, and the other one is called malware key. It has also added two values, and look, this value is located in HKey user software Microsoft Windows current version run. Does that sound familiar? It should, because this is the registry path where you would add programs that should automatically start on startup. So looks like the program, it added a value called evil value. And it has also added another value, hello malware, under malware subkey malware key. Now let's take a look at the modified values and see if we see anything interesting. So this cryptography stuff we can usually ignore because this is the value that always changes in Windows. It's used for generating random numbers. So it's periodically updated. And in Windows Current Version Explorer Assist, this is also pretty standard stuff. I'm not too shocked by any of this. Of course, I want to look at the whole thing. But yeah, I don't really see anything suspicious over here. This is the standard Windows stuff. And we see some stuff with the internet settings. And once again, folks, a lot of this is very standard stuff. So really, the only interesting things that I've seen is this and that. So to my notes, I'm going to add the following. I'm going to say that this malware adds two keys, which include malware subkey added under HKU, and also underneath the malware subkey, it also creates another key called malware key. In addition, the malware also adds two values. So first, it adds a value called evil value. It's added into HKU software Microsoft Windows current version run. Now, we know that basically malware adds a command to Windows startup. But what exactly is that command? Well, what we have right here is the hexadecimal characters that represent an ASCII string that represents the command in question. We can convert those ASCII characters into a ASCII string by going to the websites such as this one, rapidtables.com, pasting it into the upper box and then clicking convert. And it will give us the resulting ASCII string, which is evilmalware.exe. To summarize, this value basically represents a command evilmalware.exe that malware adds to the Windows startup. So when the Windows is rebooted, evilmalware.exe is going to be launched. The second value, called hello malware, is created underneath HKU malware subkey malware key, and it has an integer value that is set to 1. Now, we don't know exactly what those values represent yet, except the evil value, but we're going to take a note of them. Also note that we can also check the Windows registry for those values to see them firsthand. By the way, I haven't seen any networking activity in the PATE DNS, so no attempts for DNS resolution. Now, I did see some stuff in Wireshark, but let's see if we can find anything suspicious here. So this doesn't look suspicious to me. It looks like standard Firefox communication. This looks like another DNS request. I don't see anything suspicious about it. ARP, that's general networking stuff. More communications with Mozilla. That's Firefox doing its thing. I could have probably eliminated that if I closed Firefox while I did all of this. And some TCP message. I don't see anything suspicious here in the packet contents or in the communication itself. This is more standard stuff. It looks like just a standard DNS query for something. I'm going to stop the capture so no new stuff comes in. So it looks like TLS protocol. This is to open an encrypted session. Once again, that's probably Firefox doing something. Yeah, so all of this is TLS. Another TCP message. I mean, once again, based on the packet contents, I don't see anything interesting in here. Of course, they could be encrypted. More TLS, more standard stuff. Yeah, so far, by looking at this, I don't see anything that jumps out at me. And browser, that's more of the networking stuff. Yeah, so I don't see any network activity that jumps out to me as being suspicious. And of course, I can check each of those IP addresses by Googling them and see where they're located and who they belong to. And I'll find out that they are not malicious. And a lot of those addresses over here are actually internal to the network. So like, for example, this is an internal address. So they make no sense in the outside world. So anyway, nothing too suspicious in Wireshark. So I haven't seen any network communication. Now, what I do want to look at is the Procman and see what actions this program takes. So we have the standard process startup stuff. It's loading some of the dependencies, nothing too interesting here. And all of this is part of the loading. We have seen this before. So I'm just going to scroll down, and this is more loading. It's loading the DLL files it needs. And in the above, it was just loading the executable image. Yeah, more dependency loading. Now, you see it's loading advapy32.dll. We saw this with the dependency walker. So I'm not surprised it's loading that. And now it's loading the program image. More dependency loading. Image loading, more dependency loading. Now, what I'll be looking for is registry activities that are related to what we observed with Regshot and other tools. So this looks like a pretty standard registry thing. So it's just opening this key to see something about the version number of something. So, and it says name not found. So don't see that as very suspicious so far. And let's see. And then more dependency loading, more dependency loading, image loading again, yeah. Now, I do see some registry activity over here, but it looks like it's related to loading dependencies. I see those DLL files. So it's reading those registry entries just to get a hold of the DLLs, most likely, to find out perhaps where they are. And then more DLL loading. This is a pretty standard stuff as well. It's looking at anti-user dat log. Now, I see this, reg key create. So this is where it creates the malware key in the registry. And you see, the operation is reg create key. And actually, before we saw this being imported during the static analysis. So here we see it being used. Here it looks like it's closing malware subkey. And once again, we've seen it in our static analysis before. And we have set value of the value hello malware. And it says that the length of that value is 4. And then it's closing that key right here. And now we see it's creating a key in Windows current version run. Now, the question is, what key is it actually trying to create? This is probably one of the keys that we have observed right here. All right. It's probably creating either malware key or malware subkey. And then down here, I see that it's setting a value inside Microsoft Windows current version run evil value. And it sets it, it looks like, to evilmalware.exe. And once again, this is corroborated by what we have observed before. All right. And then after this, we got some more standard stuff, and then it's over. Okay, the program exits. Now, let's put together everything that we learned and try to come up with some kind of a conclusion. So overall, we can conclude that the mystery.exe executable, it adds an executable evilmalware.exe to the system startup by adding a value called evil value to HKU software Microsoft Windows current version run. We're not clear on how evilmalware.exe arrives in the system, or even if it arrives at all. We didn't see any signs of the malware being downloaded to the system. We didn't see malware, for example, being decompressed from something else onto the system. In other words, no evidence that evil malware ever arrives on the system. This means that we may need further analysis, specifically advanced static and advanced dynamic analysis, to see if perhaps evilmalware.exe does indeed arrive on the system, but our basic techniques just fail to reveal that, or maybe it will just confirm our current suspicions. If that is the case, it could be that this malware sample contains bugs, or it could also mean that perhaps this malware sample is part of a bigger attack and its only purpose is to serve as a decoy. This is a feature of some of the more advanced attacks out there, especially attacks that originate from state-sponsored groups. We have also observed that malware also adds a value called hello malware to the registry, and we also observed that it adds keys HKU malware subkey and a key HKU malware subkey malware key, and hello malware is added under malware key. Now, I have also used regedit in order to confirm the existence of the registry entries that we just discussed. So here is the evidence of that. This is the evidence of malware subkey, malware key, and the hello malware value. This is the evidence of evil malware.exe being added to HKU software Microsoft Windows current version run, thus setting evil malware.exe as a startup program. Now, the function of hello malware value and the keys malware subkey and malware key is not clear. It could be that, once again, our basic techniques fail to reveal their significance, or it could be that we need to do static and dynamic analysis techniques that are more advanced that can reveal what those keys are. Another possibility is that the creation of hello malware, malware subkey, and malware key is just a decoy activity meant to distract us from some other bigger action that this malware is supposed to perform. So that is our current conclusions, and hopefully we'll be able to reveal more with more advanced static and dynamic analysis techniques. So please take time to review this tutorial and all of the techniques that we have learned, practice them, and try applying them to the other two exercises in the basic dynamic analysis unit. We will go over those exercises in class. All right, thank you for watching this tutorial, and I'll see you very soon.